That's perfectly okay. So, welcome to the CPA approach. And in order to focus on a particular topic, uh, can you go on mute because your background noise is coming, Aditi? You can unmute when you have something to say or use the chat. Yeah, thanks. So CPA, in order to focus on a particular topic, because we should always focus CPA with the topic, I have taken preparatory years of maths as NCF. So this is the overall session, which will run for about 50 minutes, traditional versus CPA approach. And then what is CPA? Couple of classroom videos to show CPA in action. What does it mean for a good teacher to be a CPA teacher? And then questions and answers. So this is the session coverage. And to begin with, I will ask you a question. How do you solve 13 divided by 4 in a usual algorithm way? Can anyone answer? You can unmute yourself and tell me. How do you usually solve 13 divided by 4?
By long division method?
Yeah. So, suppose I give you a task. If you brought what I asked you to bring 13 items, I'm going to give you a resource. How will you show this division using these 13 items? I'm going to send this here. I'm putting this in the chat box. You can open it. You can also download it for yourself and use it. You can view it and download it. Now see how they have showed how to do division. How do you think what do you think you will do if I say 13 has to be divided into 4? So they have created 3 squares, 1 is remaining. So the way we write this is 13 divided by 4. I'm getting 3 complete squares and 1 left over. So this is the quotient and this is the remainder. Now, on the document which you can download, if you have 14 and you're dividing it by 4, how many squares do you think you will get here? If you have 14 sticks and you're designing squares using them, how many squares will you get here? Can anyone share? No? No one? Okay. Yeah. Yeah, Payal. So how many squares? You get 13 squares. And what is the remainder? What would be the remainder? What would be the leftover sticks? So you have, let's say, 14. Yeah. So how many squares would you be able to make? You said 3. I'm making squares. 1 square. How many sticks have gone in 1 square? 4 sticks have gone. So then I make another square. Again, 4 sticks have gone. Then I make a third square. How many sticks have gone by now in total? Are you typing on the chat? How many sticks have been used by now? 4 and 4 and 4. And then we are remaining with 2. So this is how 14 is. Now, suppose the question is 15. And I want to
Ma'am,
make...
what
Yeah.
you're doing, I think we can't see that screen. We can see the same picture what you are showing before.
Okay, wait. I'm so
Because we
sorry.
can see the 13 one.
Yeah, I had opened a Jamboard. I'll just open this again. This is what I was showing. Can you see the whiteboard?
Yes, ma'am.
Yeah. So thanks for telling me this. Now, suppose you have 15 sticks. So I want to turn this into squares. So how many squares can I get using 15? One. Then how many? Can anyone tell me? You can go a little fast here.
3 squares, we will get complete three
And how
squares.
many? Yeah. And how many left over? How many?
Three.
Three. So what we say is 15 divided by 4 gives us 3 full and 3 as leftover. So this is what this division worksheet means. And after this, I'm going to ask you a question. What is the pattern? But my main question would be, why is it that the number in leftover column will never be more than 3? Why will this be never more than 3? Can anyone answer?
Yes, ma'am.
Yeah,
If it is more than 3, like 4, then
right,
that 4 will like make one complete square. So we will count
right.
that in square.
Absolutely. And those of you who've joined just now, I have shared this link in the chat box. Yeah, then it would form a complete square, correct? And at the end of the session, I will give you a downloadable PPT. So you can maybe focus and you don't like have to take notes. That's the whole objective. So what I'm trying to show you here is, this is what is CPA. You start with something concrete, you move to pictorial, and then you move to abstract. This is a typical example of a worksheet in CPA. So kids in a class, when they are working with CPA, generally have concrete material, paper with pen, pictures, everything happening in sequence, but at the same time. And why do we do it? What's the use of it? That we will come to as we move. And I will be pausing also strategically to give you a chance to say something or ask questions. So CPA is multisensory. It's activity based. Pupils engage in activities and they learn maths concepts and skills. So you have concrete objects, you have pictures, and you have an abstraction which comes in the end. Anyone knows who invented CPA? So Jerome K. Bruner, he said children should have action, image, and language-based learning. In our education currently, or the way at least I was taught, we went straight to symbols. And therefore, maths remained a very enigmatic subject for everyone because we couldn't relate it to concrete objects around us. So, what Bruner said, action, image, language from simple to complex, when a curriculum is created like that, that is when children learn, and he called it a spiral curriculum. And CPA is now a big thing. It has come into NEP finally, although it has been done by teachers across India for decades. So let me take more example from number sense for CPA. Now, number sense is an intuition about numbers and their relationships. If you have seen, there are people who are very quick with numbers. And number sense can't be taught, it has to be caught, which means that when the kids are doing something, they are engaging, let's say, in an activity like the activity I showed you with sticks, and they are creating squares and then writing, the brain makes sense of it automatically. So the teachers have to design the classroom in such a way that the brain makes sense of what the concept is all about. That is what number sense is. So I'm going to take an example from multiplication and then division and fraction to do this. And I'm just going to present it again because now I'll take a single Chrome lab as I'll be showing you some videos also here and need the sound for it. Is the screen visible?
Yes, ma'am.
Yes, ma'am.
Okay, thank you so much. So we are here, multiplication. So for example, a very popular tool is used for, and this particular slide is from SAR Education, so their tag is here. A very popular tool is used to do multiplication. So what I'm going to be doing is showing you concepts. What are the tools which can be used? Then I'll also give you a resource which has all possible tools that any primary school in the world should have. And Dean's Cubes is one of them. And these can be bought or these can be made in school also. Now, if you have seen Dean's blocks, if you want to work out 14 into 12, you're going to write 14, 12 on one side, 14 on the other side. And now we are multiplying it. So when we multiply 14 by ones, it's 14. This 14 by 1. Then we multiply 14 by ones again. And then we multiply 14 by tens. And we get this. And then we simply regroup and add this. And we get the answer as 168. All of these put together. Any confusion here? Blue one is 100. 6 is, yellow ones is 6 and 8. So answer is 8. So when CPA is done, how kids would be working it? They would be having the concrete there. They would also be doing abstract side by side. Now, there is a lot of different ways people are doing this. In a lot of classrooms, or rather the standardized way of CPA is, let the children first work out using the concrete material. When they have a good grip on it, they graduate to concrete and pictorial, which means that they just draw. There's a teacher who used to do, she used to say square, rod, and dot. And the kids used to use these shapes to do, and then finally they go to abstract. So I'll just show one demonstration of how this is done. In case the audio is a problem, please let me know, although it should work well here.
This video will show you how to use Dean's cubes to multiply a 2-digit number by a 1-digit number.
Is it audible?
Yes, ma'am. Audible.
Okay, thank you.
The multiplication I'm going to solve is 39 multiplied by 4. As I'm using Dean's cubes,
So this is a demonstration of full CPA. You can see he has the P here, the images, he has the numbers, and he has the Dean's cubes also.
puts the correct cubes on the correct number. So in the ones column, I have got 9 and 4. This means I must put 9 cubes on top of the 9 and 4 cubes on top of the 4. In the tens column, I've just got a 3 here. This represents 30, so I must use my rows of 10 cubes and put 3 of them on top of the 30. First, I must solve the multiplication in the ones column. This is 9 multiplied by 4. I know that 9 multiplied by 4 equals 36. 36 has got 3 tens and 6 ones, so I will need 3 rows of 10 cubes and 6 ones. The 6 cubes here go into the answer part of the ones column. However, the 3 tens that I've got here must go underneath the answer section to remind me to add them on in the next step. I'm going to write a 6 here to show the 6 cubes here.
Now, just wanted to highlight this here, that CPA is happening simultaneously, which is the ultimate objective of a CPA-based class. But teachers can also start with doing lots and lots of concrete work, write, draw simultaneously, but ultimately the children should be able to come here.
Next, I must solve the multiplication in the tens column. this is 30 multiplied by 4. I know that 3 multiplied by 4.
So I'm pausing this. It's a long video. 3 minutes is a long video for an hour's workshop. You can watch it when I send you this, and it's from YouTube. So it's an open source, which you can
This video will show
get it. Any questions here, or shall I move to division?
Move to division, ma'am.
Okay, thank you. Now, in division, there is a catch here. So division, the demonstration would be, I have already showed you using, let's say, lollipop sticks, but we can also use what are called place value counters. Now, one can use Dean's cubes. One can also use counters. Depending on the school, depending on the resource capacity, depending on the topic you're doing, depending on the children, it can also be done using a place value counter. So let's have a very brief demonstration of how place value counters can be used. And this is the same question, 42 divided by 3, which we did using ice cream sticks in this worksheet that I shared with you.
Sharing using place value counters. We're going to look at the calculation 42 divided by 3. As you can see here, I've got my place value counters to the value of 42. 10, 20, 30, 40, 41, 42. I'm going to start off by sharing these into 3 sections of a place value table. So I'll start off with my tens. I can put 1 in each in the tens column, and I've got 1 left over. Okay, so what I'm going to do is I'm going to exchange that 10 for 10 ones. Okay, so I've now got 12 ones. I still have the same value, 30 and 12. It's still 42, and it now means I'm able to share that equally between 3 parts. So I'm going to put 4 in each row. And that means there.
So here he has showed concrete using the concrete material.
Which gives me 10, 11, 12, 13, 14 in each group. So 42 divided by 3 equals 14. As we move away from using the concrete manipulatives, you can still do the same thing, but by drawing the place value counters. So I'm still doing the same calculation, 42 divided by 3, and I started off with 10, 20, 30, 40, 41, 42. As I shared them out, 10, 20, 30, I had the 1 extra 10 that was left over, and I exchanged that for 10 ones. I was then able to share out the 12 ones equally into the 3 groups to give me 1 10, and 4 ones in each group. Okay, so I have 14, 14, and 14. When we move on to do this abstractly, we're still doing 42 divided by 3. We can refer back to this previous knowledge that we can partition 42 into 30 and 12. So 42 equals 30 and 12. These are both multiples of 3. Okay, so I can then do 30 divided by 3 equals 10. And I can do 12 divided by 3 equals 4. Finally, if I add these two together, 10 plus 4, I get my...
So this is a great demo of all the 3, like concrete, pictorial, abstract, all the 3 together. Any question here? Anything that struck you? Like I always wonder whenever I see CPA in demonstration like this is, how would teachers get the time to do all the 3? If any one of you has tried CPA in classes, would you like to share something? Okay. Payal has a question. How do you approach? So CPA can be used for higher classes, but generally CPA is more suitable for the primary classes. So I'm going to go up to fractions, which does come in middle school. For algebra, generally Cuisenaire rods are used with the CPA, which is similar to the concrete material showed here. But this particular session will be focused till about, let's say, grade 6. Till then, it would be used. Any other question? Any question? Anyone? Any other comment? And since this is a small group, if you put a chat here, I may not be able to see. You can also unmute yourself and say. So this is complete CPA for division. Now, place value counters, how CPA works is that you take smaller numbers and you divide and then ask the children to come to the pattern which the gentleman came in the end. When he came in the end, he came to this pattern here. So when the children have come to this pattern, after that, they should be able to do it using long division. Because CPA, one of the problematic things is that it can work for smaller numbers, but when you come to larger numbers, then it can become a big problem. As you can see, the number of counters are going on increasing. You may be able to do one or two problems with it, but not as a continuous sequence, because then it will be like, it's going to be very time consuming and resource constraint will also be a lot over here. So that is one thing one needs to remember with CPA. Start with small numbers, bring the children to abstraction, and then when you go to the larger numbers, then they should be using the abstraction. So the C and P is like a bridge which gets kids to the A, which is abstraction. Any questions or comments still here, apart from what Payal has written, that some examples of middle school? Any other question or comment? Okay. So I would move then to fractions. And here I'll show you small bit of a class, not the complete video. And then we'll move to a tool called as fraction wall. I just want you to see how a teacher can use a tool and this obviously is a middle school class in that country. And the teacher is using the tool in a large class in a very simplified manner.
So today we will be developing a deep and secure understanding of adding fractions.
Key Stage 3 is a Cambridge curriculum of middle school.
Okay, so you might already have an idea of how to do this already, but a lot of students make mistakes when it comes to adding fractions. Well, students in general, whether they're in year 7 or whether they're in year 11, always make the mistake of adding the numerators and adding the denominators when they're doing any kind of fraction question to do with adding or subtracting. And what we tried to achieve, or what I tried to achieve in that lesson, what I wanted the pupils to see was that actually they need to be equivalent. Your starter is to find the lowest common multiple of two given numbers. As an example, I've written that the lowest common multiple of...
So she's starting with a very traditional approach and then she will move to the concrete side.
3 and 4 is 12. Why is that the answer, Shemaraya?
It's in both of their timetable. Like if 3 times 4 is 12 and in 4 times 3 is 12.
Fantastic, very good. How do we know that 24 is not the lowest common multiple? Because that's also in the 3 times table and the 4 times table. Scarlett?
Because 12 is lower than 24 and you're finding the lowest common multiple.
Very well done. What I would like you to do is to shade in a third on your fraction wall, okay? So you're shading a third on your fraction wall. We decided to use the fraction wall to help pupils gain a deeper understanding of what equivalence is and what adding fractions is really about. Can you now shade in another third on the same line, please? What we really wanted to do was to go back to the basics and understand what fractions are, why the fraction wall is helpful, and why it's useful for us to add fractions together. What sum have I just asked you to do?
A third plus a third.
Can somebody else tell me the answer to that question? Pascal.
2/3.
So what you did was you shaded in a third, okay?
Okay. So let's go to the tool that she's using. And it's a fraction wall. How many of you have already used this? I'm not very aware of your CPA action plan or works. So if you have used it, please feel free to share. Otherwise, you can download it. It's in the chat box. So fraction wall is something that shows very clearly how 1 is divided into fractions in so many ways. You can have a full wall with numbers, or you can have a blank wall and ask the children to make it for you. And using this, let's look at the solution to which fraction is greater. Now, I would ask you, how would you normally do this in the classes? Which fraction is greater? Something which the teacher was doing in the classroom. Would anyone like to quickly share how would you normally do this in classes?
For introducing this subject, we generally give the rectangular strips. What you are saying,
Okay.
the fraction ball, same
Yeah.
only the rectangular strips and
Yeah.
dividing into equal parts. So
Absolutely.
like three parts, and then rectangular white strips I used to give them, and they
Yeah.
will color it. How many parts are there? Like 2 out of 3
Absolutely.
parts.
Great. We'll be coming to the strips also. And in a standard algorithm, anybody else wants to say something? Somebody was trying to say.
No, actually I was trying to say, but at a higher
Yeah.
level,
Yeah.
we try to make the denominator same and then compare the numerator part.
Absolutely, absolutely. So at the junior level, when you do fraction wall, what you ask the children is simply color 2 by 3, color 3 by 5, which is bigger. And so the children color it. Maybe they have a fraction wall, fraction strips, as ma'am was saying, which I'll be coming to in a while. And they can even draw it. First, they need to see the connection between this and this. And then the abstraction is a jump that happens in the mind. When they, as they say, the cells in the brain, the neurons, they click. And suddenly they can do it in abstract way only. And if your CPA is successful, as many people say that when we are able to, yeah, Aruna ma'am, thank you so much. You teach higher classes. It will be great when we have a discussion if you can also share how this can be used for higher classes. So I was coming back to this. A lot of people say that the children are able to do math. Like I was with teachers in the southern part of India, and the teachers were saying, when we do activities, the kids are able to do it. But when we give them a problem, the kids are not able to do it. So then I asked them, can we have a bridge between your C and A, which is called P, pictorial? That from concrete, let them first jump to pictorial, that is draw pictures and do, and then abstract. And if you don't have time, then let them just do pictorial and abstract. And the next time I went there, they said that things were different. So that is why CPA runs in a sequence. If time is a crunch, do PA, maybe CA. But basically, before the kids come to abstract, there needs to be a foundation below. That is when the fear of math is has no place in the lives of the kids. So this is where I'll share with you what ma'am said about fraction tiles. Fraction tiles are simply fraction strips. You have them horizontal and then you can just cut them. So I'm giving you this document here. And fraction tiles is, let's say you have to add 1 by 2 and 1 by 3. So I have my 1 here. I have my 1 by 2 and 1 by 3. Now I need to know where is 1 by 2 and 1 by 3. Is it going beyond 1? Is it less than 1? So I'm going to look for tiles which are covering both. So 1 by 4 is not covering both. So I remove it. Then I look for tiles, another tile. Again, it's not covering this. Then I look for something else. Now this is covering both 1 by 2 as well as 1 by 3. So I have got equivalent fractions here, 1 by 2, 1 by 3. And now I can easily add both and get 5 by 6. So fraction strips, and I'll show you another demonstration video later, is when you cut them horizontally. Subtraction of fractions, it's interesting. You again start with 1. You have half, and now you want to cut 1 by 3 off it, and this white portion is the answer. So this difference is the answer. So once again, I'm going to look for tiles which cover both. Not working. This is working. Now when I need to subtract, all I can see, 1 by 2 is same as 3 by 6, 1 by 3 is same as 2 by 6. So I subtract and the answer is coming coming to me very clearly. Now, what happens is the kids are doing this with their hand. They are looking at it as a picture, and they are also doing it in abstraction. When these three or at least two of these things are happening together, the brain is forming connection. And at this age, at the primary, why we insist so much on concrete objects is that the children are more like, the body is developing in childhood, then come the emotions, and then the logic starts around. If I remember when I was teaching, it's about grade 8, although now the generation is literally changing very fast. So in the primary, the kids are in their bodies. Therefore, anything they learn, if you teach with anything concrete, the motor skills, when they are involved, the connections in the brain happen. Whereas in the middle school, they say that bring a lot of emotional enrichment in the classes. So middle school is where I used to do a lot of multiple intelligences, coloring, art, music, drama. But for primary, there is nothing like starting with concrete. So showing you a short demo of how fraction strips work. It's a very long video, so I'll just show you maybe snippets of it. You can have a watch later.
Okay, welcome back. In this video, we're going to talk about a second strategy that we can use to add fractions with unlike denominators. And in this strategy, I'm actually going to be using fraction strips to demonstrate how this can happen. So in the last video, what we discussed was what a fraction actually is. And I showed you some Cheez-Its, I showed you a Hershey bar, and we kind of briefly discussed that the whole of a whole, if it's cut in, it's going to be my whole. And sized bar, but 3 becomes my whole into 3 parts.
So these are fraction tiles. It's a fraction wall which is cut off.
So now 3 becomes my whole number. And 2 is my part. We'll get to that in a second. And my second fraction, my whole, what I want my whole to be broken down into is 4 pieces. So now I have another whole that's broken into 4 pieces. So that's why 4 is my whole. Now I'm going to go ahead and start the adding piece. So I want to pull out 2/3. I'm going to take this one away because I don't need it. And I want to pull out 3/4. Line it up, and I'm going to explain why I'm going to line it up in a second. So when we add 2/3 plus 3/4, we can't actually begin adding yet because our wholes are different. What I can say is by looking at this, I know right away that my answer is going to be greater than 1 whole, because when I place all of these together, when I place 2/3 plus 3/4 together, it passes 1 whole. So I know when I do the calculations, my answer is actually going to be a little bit greater than 1 whole. Now, what I'm going to do is I'm going to put 1/3, 2/3 here, and I'm going to bring 3/4 down here. What we want is we want to find an equivalent piece that will fit both 1/3 and 1/4. So if I look at 1/6, for example, and if I line 1/6 up, 1/6, 4/6, find something that is equivalent to 1/3 and 1/4.
So it goes on. Basically, I wanted you to have a demo of how horizontally fraction strips work, and she would find something equivalent and she would demonstrate. So this is the C part of CPA. Any questions or comments here so far? No one? Okay. So what is CPA? I think here, even if you're not in primary, you might find it at least the main understanding of CPA. CPA says that use actual objects to solve problems and facilitate hands-on learning. And some of these objects are given, which are time tested, which are research backed up, but any concrete object can be used to initiate a topic, whichever grade you are, whether you are, let's say for algebra, as ma'am was asking for middle school, there are objects like red buttons, blue buttons. Red buttons are X, blue buttons are Y. So the children are given, let's say, lots of red buttons, blue buttons, and ask them, can you demonstrate for me 2X plus 3Y? So they would have 2 red and 3 blue buttons. And when they do that, next to it, they will also write 2X and 3Y. So that association between concrete and abstract happens in their brain when they are using these manipulatives by hand. The other thing for algebra is Cuisenaire rods, which are also used, but you can also use like, I conducted a workshop where I just took chana and rajma and I showed how so much of math from 1 to 8 can be done using this. So let's say your chana is X and your rajma is Y, and you just have to give it to the kids. There was a colleague of mine who used, let's say, 2 different types of toffees to do algebra in the class, and at the end of the class, everybody ate it, and that was a very happy algebra class. The second part of CPA is use pictures to approach and solve problems. Now, the pictures can be same as the concrete objects drawn, or they can be different number bonds. Pictorial method is unbelievable, even in middle and senior school. Anytime a child is not understanding a concept of math, you can just ask them, can you draw it for me? If a child says, I don't know how to solve this word problem, let's draw the word problem. So even if concrete, slowly in middle school, concrete drops away, but pictorial is like one strong foundation that should stay with the kids till grade 12. And then you come to abstract, where numbers, letters, and symbols are made. But there should be a very strong connection between pictorial and abstract. So why is CPA important? It gives children time to investigate. Pictorial, for processing in the brain, pictorial is a great way. It's like when we want to go somewhere and we draw a map to find our way, pictorial is like that. And abstract runs alongside concrete and pictorial, which enables the children to show their understanding and make the jump to the abstract. So common myths are that manipulatives are for children who are struggling. Not true. Hands-on concrete resources are for early years. Not true. There are teachers who have used concrete material for even higher classes. Teachers choose the manipulative. Not true. There are children who have demonstrated to me what symmetry is all about using their own material. CPA is a hierarchy or a straight line. Not true. The other day I was talking to teachers in a school where they said that the children are just not able to get using CPA. So I asked the teacher, have you tried APC or PAC? And she said, actually, yes. But I didn't want to share because I was scared that CPA has to be a straight line. It doesn't need to be a straight line. You can also start a class, let's say in higher classes or in primary. You can also start by saying, okay, what is 2x and 3x? Can you draw and show me what does 2x and 3x look like? Like I have also done things like asking the children, what are like terms and unlike terms? And when they did it, I said, can you do a little drama and show me like and unlike terms using real objects? And the kids were able to do that. So it can be turned around, turned on its head. The very traditional thinkers think that it's a straight line, but there is a very strong thought that this is a myth. Any questions here? Anyone wants to share? If you want to share an example of how you have used it in primary or middle or senior. It's a quiet group. So CPA in action is again, as my favorite way of showing anything in action is via video. Now this video is made by NCERT. It's in Hindi with English as a background. And it showed, this is a pilot class that the teacher has done. And I'm using the fraction as an example again, just to show that you don't really need a lot of great resources. Even if you don't have fraction tiles, it's possible to do CPA in the class.
नहीं बनी है। आज कुछ और गतिविधियों से इसका और पता लगाती हूँ।
दो भाई मिलके खाना खा रहे थे, उनके पास एक रोटी बच गई थी, तो एक भाई ने कहा चल इसका हम आधा आधा कर लेते हैं। क्या कहा उसने? और उसने रोटी उठाई और उसने उसके दो टुकड़े कर लिए, ऐसे उठाया और ये।
So she is using a simple circular paper as a chapati and she's going to do the entire CPA using.
ये दो टुकड़े, क्या आप मानते हैं कि ये आधे आधे हैं? क्यों ये आधा नहीं है मोहित?
क्योंकि मैम एक बड़ा है और एक छोटा है।
क्योंकि
So she goes and she does in this form only the entire class. And then she comes
ये
on
आधा
the
है
board.
कि ये? अनिकेत आप बताओ। रेखांकित वाला आधा है, इसका मतलब ये आधा नहीं है। पक्का ये आधा नहीं है? अभिषेक
दोनों आधे हैं।
दोनों आधे हैं। भाई अनिकेत सही बोल रहा है या अभिषेक सही बोल रहा है? क्यों? आप बोलो नंदिनी। क्योंकि दोनों
So this was just to demonstrate you that if there are resources available in the school, such as fraction tiles or downloadable from internet and cutting them, it's great. But if you don't have resources in the school, then also with simple material, this can be done. And Payal has a comment, while teaching grade 4, I had used this concept of a class picnic of dividing sandwiches and rotis, demonstrate, amazing. We drew and then which they had to shade. Perfect. This is a perfect example of starting from concrete, involving stories into it and then.
बराबर है। कौन बच्चा लिखेगा कि आधे को कैसे लिखते हैं गणित में?
So look at the strategy she is using. She is using story, concrete, pictorial, abstract. She is also bringing peers.
याद करो, आधा शब्द पहले सुना हुआ है। आपने क्या गणित में
बटा हुआ है मैम।
And she's going to bring kids
जिसमें
to the board to do them. This is a beautiful video. I would recommend you watch it when I share the PPT with you. So what we need to do in CPA is, first is a very clear understanding of concrete manipulations. And this is a beautiful quote that if we do not use concrete manipulations or concrete manipulators, we don't understand math. But if we do only concrete manipulations, we are not doing maths. As the teacher in the southern part of India in Vilupuram had told me, and we are only doing concrete and the kids are not learning math because abstraction has not happened. And mathematics, end of the day, is the capacity to do abstraction. You need to come to a point where you think 11 and 11 and you do 22 and you don't have to look for Dean's cubes or shapes. So C and P is like a support. It's a ladder to bring the kids to abstraction without having fear in the way. So this is the thing to understand the manipulatives. For that, there are a number of resources which any school should have. And these can also be built in-house, you might have seen. And here is a whole list that you can explore at leisure. This is a resource for you. So understanding concrete manipulatives is the first thing. What is a place value counter? What are these blocks? What are arrow cards? What's a tangram? What can I do with it? What do I do with the fraction wall? What do I do with the square? In how many ways can I use a geoboard to teach math? It's like a bit of understanding of concrete manipulatives is needed. Second is understand the whole learning cycle. As Kath Murdoch says, inquiry cycle. is to starting with provoking the kids, making them think, asking questions, research, data, share insights. There's a whole cycle of learning that happens, which is captured here in 8 steps of building a lesson plan using CPA. Choose a very small topic to be taught. Let's say in middle school, it's a linear equation, or in primary, it is adding two whole numbers. Write the learning outcomes. Then think, where do I need CPA approach? I don't need everywhere. Then which manipulative is best for me? If I'm adding single digits, maybe a 10 frame is fine. If I'm adding double digits, maybe I need Dean's cubes. If I'm adding large numbers, maybe I need the full Dean's cube set. Then create pictorial questions. I'm going to ask the kids to maybe draw a 10 frame on paper and then create abstract questions and check the flow. Add more strategies, ask the kids to use math talk, explain what they are doing. But this is generally how the lesson plan flow works from beginning to one. It's a standard flow, even in senior school, middle school, wherever you are. Choose a small math topic, linear equations, 2-3 learning outcomes. Which manipulative can I use to teach linear equations? Okay, in my class, red buttons are X, blue buttons are Y. So I'm going to give kids 2X plus 3 is equal to 7. Solve it. So they are going to write 2, they're going to put 3 buttons, 4, and I want to know what is the cost of, what does one button represent. So, and then create pictorial questions, abstract questions. So this is a standard flow that works all our lives, actually, whenever we want to learn anything. And finally, I would say, as this is Kath Murdoch's learning cycle or inquiry cycle video, is I think I was talking to a group of teachers where I go in Delhi, and the teachers told me, why am I not able to use this material? Or I made a lesson using this material. I said, what do you think? So understand your own strengths and limitations. So for example, when I was teaching, my strength is projects. My strength is creativity, dance, drama, art, history, everything in math classes. My colleague's strength was concrete activities. So her class kids were always using paper, one-sided paper. They had scissors and all in hand. Another colleague, we were 3 colleagues teaching 6th, 7th, and 8th in the IB school where I taught. And the third colleague, his strength was integration of technology in classes. So I knew if I had to do an activity, I could go to one teacher. They knew if we need projects, we just have to call Monica, even midnight, she will send us a project on any topic. So understand your strengths and limitations. Even when you're doing CPA in class, what am I good at? What am I not good at? If I'm not good at something, can I ask for help? Is it necessary that I have to do that part? Ultimate aim is the child has to learn math. That's it. Whichever method is used, it's fine. So if you're using CPA in your own sweet way, which is leading to the child to learn math, that's also okay. So this is like understand your strengths and limitations.
I think one of the key differences that make an inquiry teacher what they are is their the way of seeing the student, actually, that they see the student first and foremost as a competent, capable, curious, almost partner in learning. So they see the light in each child. They find it, they find what it is that makes that student intrigued and interested. And there's always something in every.
So she's going to be talking about a lot of strengths that any child, any teacher who teaches CPA is one of the inquiry ways of teaching. And what I would like you to do is listen to her and see what's my top strength among the strengths that she's talking about.
Everyone. Inquiry teachers ask more than they tell. They do tell, but their dominant way of working with students is through questions and through the right kinds of questions. So they know how to scaffold.
And the reason this is important, what she's talking about for CPA, is that when the children are working with concrete material or pictorial or abstract throughout. The teacher is not standing back watching. The teacher is going from group to group, and the teacher is asking questions.
There's a kind of image of the inquiry teacher as this kind of laissez-faire, hands-off teacher that simply lets the kids do what they want. That's been a very persistent image, and it comes from some poor iterations of inquiry. But in fact, the opposite is true of the best inquiry teachers I know. They are teachers that know how to sit with the student, to carefully scaffold. They know their curriculum so well that they can move with the students' interests in order to come to that curriculum. They have a very strong repertoire of strategies and approaches. I mean, in some ways, when you think about teachers that might rely on a textbook to do the work for them, or that, and I still see it, that simply give kids worksheets to fill in, surely that is abdicating responsibility.
Yeah. And that's it from my side. Any questions? Any comment? Here is the PPT. And here is a small feedback form for you. If you can fill it, it would be great, because I would really come to know if this was relevant to you or not. Any questions, anyone?
Any resource
Yes,
link?
Monica.
Any resource link from where we can get more ideas for which manipulatives we can use for particular topic?
Yeah. So if you look at the document which I have given of resources, that has not just tools, but also how to use and how to, how to make them yourself, how to build them yourself. That document is there on the PowerPoint. I also put it in the chat box. So that has the full spectrum of resources that a school may say. Yes, Mr. Rajesh, you wanted to say something?
Yes, Monica, ma'am.
Anji.
Actually, I'm teaching in IGCSE higher grades, like grade 10, 11, and 12.
Okay.
And yeah, I thought this is something related with IB, and I registered. But I'll understand few new things, what I can say.
Okay.
Means from my day one, as I'm teaching in higher grades, I generally use abstract way of teaching only.
Okay.
But here I understand that, okay, means along with abstract, if I am able to introduce some picture or some material, then it will be
Yes.
much more easier to understand concepts.
Absolutely. You made my day, and your kids will be so happy. And you can just Google. I used to teach 11 and 12, let's say Pascal triangle, and Pascal triangle
Right.
has so many in IGCSE, IB, has so many of these little things you discover, patterns, and color it. And there are so many ways concrete or real life or even pictures can be brought in 11 and 12. I think your kids will be very happy. Yeah.
Right. What I understand that it will it will be a fun.
Yeah.
Okay, if I try it, yeah.
Yeah.
So
Yeah.
I will search on Google that
Yeah,
how I can
absolutely. You
at
can
higher.
easily, like one of my colleagues, in fact, my principal in the IB school, I used to teach in Pathways in NCR, and Mr. Umar Jafar. So he used to start probability, let's say, by giving the children dice and saying that we are playing a dice game, and write down the combination that will come, and which combination is a winner combination. So slowly kids used to understand that the winner combination is the one which has the maximum probability of coming when two dice are thrown. So they would
Right.
quickly form the sample space and they would say, okay, this one. So that is how you used to start probability. And I have also done things like asking kids to go and talk to, let's say, an insurance agent and find out how is probability used. Something I learned from my HOD, he passed away even when I was teaching. He used to ask the children for every topic, find out any one use of it. And that's a
Okay.
formative assessment. So you would,
Right, because yes, for many kids, this is at higher level. This is like a big problem. Like
it's a
when they
problem.
are doing derivatives or integrations or trigonometry. Okay,
Yeah.
their basic question is that, sir, where we are going to use it.
Absolutely. So what he used to do is, let's say you in IB, IGCSE, student strength is lesser. So he used to, let's say there are 24 kids in the class. He used to divide them into 8 groups of 3 each and say each group of 3, this is your concept, your concept, your concept. You have to come back. And in 1 minute, you have to tell the whole class, how is this concept useful? And it's a formative assessment. So he would sit with a register and pen, and the kids had 1 minute to like advertise the concept. You know, binomial theorem is a fantastic invention of humanity because it's used here, here, and here. So, and the whole class learns. You can even try that. So, concrete in primary classes translates into real life example in higher classes. That's a way to. So, I'm very happy you came, and I'm very happy you got something from here.
Yes. Thank you, ma'am.
Anyone else? Anything anyone else wants to say? Otherwise, we can wrap it up. I will send the recording when I get it in the Gmail to the group. And the PPT I've already given, but I'll also give it in the group. I hope you find it useful. Thank you, everyone, for joining.
Yeah, thank you, Malcolm.
Rest of the Teachers' Day.
Thank you, ma'am.